In this hands-on, we'll be exploring the filter function in Python. In this first example, we have a list of log entries, each a dictionary with keys for message and severity. Our goal here is to filter these logs based on severity level, so it's fairly straightforward, a simple example. We have a function here called filter logs by severity, which is a straightforward implementation of the filter function. It takes a list of logs and a severity level as arguments and returns the filtered list where each log's severity matches the specified level in the argument provided to the function. This is a simple, straightforward example of how to use higher order functions in Python to achieve fairly clean and efficient data handling through a single line instruction using filter, a function provided to the method, as well as the collection over which that function needs to be applied. Next, we examine a case in genome pattern detection. We have a list of DNA sequences here and need to find those that match a specific pattern. There's a function called matchesPattern here that checks if a given DNA sequence contains a specified pattern or not. We later apply the filter function to iterate over each DNA sequence, passing the matchesPattern function through a lambda function as an argument to the filter method. Only those sequences for which this function returns true will then be selected from the DNA sequences list and output to matching sequences. The main block then goes on to extract those items and then printing it out to screen. Finally, let's look at a stock price anomaly detection example. Here we have a list of stock prices, and we want to identify anomalies based on a threshold provided to our anomaly detection function. The isAnomaly function here defines what constitutes an anomaly. Again, we'll use filter in this implementation to process each stock price and identify those that meet our anomaly criteria. And the criteria in this function, for simplicity, is the absolute value of the difference between the price and the threshold provided to the function, checked against the threshold times 0.2. And if that absolute price difference is greater than threshold times 0.2, the output of this function is true, otherwise the output is false. In conclusion, this hands-on has illustrated the versatility of Python's filter function in various data processing scenarios, albeit simple ones, from simple log filtering to complex genome pattern recognition and stock price analysis. We've chosen filter to illustrate how Python provides elegant solutions to data selection problems, and these obviously can be scaled to far greater complexity problems as well as far greater, much larger data sources should you need to apply it at that scale. Thank you for your attention. And let's proceed to the next few lectures and associated hands-ons, where we'll delve deeper into integrating all of these higher order functions together to build slightly more complicated implementations for data selection, summarization, and reduction use cases. See you in a moment.